At 22:15 hours, USS Carney operates in the eastern Mediterranean. Arleigh Burke-class destroyer, standard defensive suite, Aegis combat system, vertical launch cells, SM-2 missiles, phalanx close-in weapon systems. But tonight, there's something different. A prototype system on the forward deck. HELIOS, high-energy laser with integrated optical dazzler and surveillance. 300 kilowatts of directed energy. This is combat power. The system cost $180 million to develop. Installation took 6 months. Testing was extensive. Range trials, environmental trials, simulated combat scenarios. Performance was flawless, in perfect conditions. Clear skies, calm seas, controlled targets. Tonight will be the first real combat test. At 22:17, the radar detects inbound contacts. Range 45 miles. Count 50 targets. Classification mixed. Anti-ship cruise missiles, attack drones. Speed 550 miles per hour for missiles, 120 miles per hour for drones. The threat is real. The ship goes to general quarters. All defensive systems activate. Traditional doctrine says engage with missiles first. Long-range kills, then guns for leakers. But the captain has new options. At 22:18, the combat systems officer presents the engagement plan. HELIOS can engage at 8 miles effective range. Time on target, 3 seconds per kill in ideal conditions. Rate of fire, theoretically 20 targets per minute. Against 50 inbound threats arriving over 6 minutes, the laser can kill 120 targets. More than sufficient. The math looks perfect. But the combat systems officer adds caveats. Atmospheric conditions affect beam coherence, temperature, humidity, particulates, spray. Weather forecast, humidity 78%. Above ideal, but acceptable. Sea state, moderate. Ship motion will affect targeting stability. The laser system has gimbals. They compensate, mostly. At 22:19, the captain makes the decision. Engage with HELIOS as primary defense. Hold missiles in reserve. This is the test. Prove the technology works, or prove it doesn't. Which force breaks first? A. Air defense. B. Naval Group C, command network. At 22:20, the inbound threats enter the 8-mile engagement zone. The HELIOS system activates. Power draw 300 kilowatts. The ship's generators handle it easily. The targeting system acquires the first target. Lead cruise missile. Range 7.8 miles. Altitude 100 feet. Speed Mach 0.8. The laser focuses. Adaptive optics compensate for atmospheric distortion. The beam reaches out. Invisible. Traveling at light speed. Impact is instantaneous. The targeting point. Engine intake. The missile's metal skin begins heating. Temperature rises. 1,000 degrees Celsius. 2,000 degrees. The structural integrity fails. At 22:20:03, the missile disintegrates. First kill. Time on target, 3 seconds. Perfect. The system immediately retargets. Second missile. Range 7.6 miles. The laser engages. But atmospheric conditions have changed. A patch of higher humidity. The beam disperses slightly. Power on target reduces by 15%. Time to kill increases to 5 seconds. At 22:20 or wait, second target destroyed. The rate is slowing. Third target, an attack drone. Smaller, more maneuverable. The targeting system tracks. Laser engages, but the drone has reflective coating. Purpose-built counter-laser armor. The beam reflects 40% of the energy. Time to kill, 8 seconds. At 22:20:16, third target destroyed. 3 kills. 16 seconds elapsed. The theoretical rate is 20 per minute. The actual rate is 11.25 per minute. At this rate, 50 targets require 4.44 minutes. But the targets arrive in 3.5 minutes. The math no longer works. At 22:21, the combat systems officer recommends hybrid engagement. Laser plus missiles. The captain approves. Fire control assigns targets. HELIOS takes close-range threats. Missiles take distant targets. At 22:21:15, 4 SM-2 missiles launch. They streak toward the 4 furthest contacts. Flight time, 90 seconds. All 4 intercepts successful. The threat count drops to 43. At 22:22, HELIOS continues engaging. The system has destroyed 7 targets, but problems emerge. The laser aperture is heating. The cooling system was designed for sustained fire, but not continuous maximum power. Temperature warnings appear. The system reduces power to 270 kilowatts. To prevent damage, time to kill increases to 6 seconds per target. At 22:23, more issues compound. The ship's motion through moderate seas causes targeting micro-adjustments. The gimbal system compensates, but it adds fractional delays. Beam dwell time increases. Some shots miss entirely. The beam sweeps past the target before achieving kill temperature. At 22:24, the inbound threats are at 4 miles. The engagement is intensifying. HELIOS has destroyed 12 targets total. 41 remain. The missile inventory has launched 8 SM-2s. 92 missiles remain in the VLS cells. Plenty of capacity, but each missile costs $3 million. The laser cost per shot, approximately $1 in electricity. The economic argument for directed energy is compelling. If it works, what happens next changes everything. At 22:25, weather changes. A rain squall moves through. Light rain, barely noticeable to crew on deck. Catastrophic for laser performance. Water droplets scatter the beam. Effective range drops from 8 miles to 2 miles. Power on target drops 60%. At 22:25:30, HELIOS effectiveness collapses. Time to kill increases to 15 seconds per target. The system shifts from asset to liability. The captain orders switch to traditional defense. Missiles primary, phalanx secondary. HELIOS stands by. At 22:26, the VLS cells ripple fire. 16 missiles in 10 seconds. The SM-2s climb and turn. Seekers active. Targets acquired. The missiles are reliable, proven technology. 14 hits. 2 misses due to target maneuvering. The threat count drops to 27. At 22:27, the rain squall passes. HELIOS performance restores, but the system is now at 240 kilowatts. Thermal management priority. The laser re-engages. Reduced effectiveness, but still functional. At 22:28, the remaining threats are at 1.5 miles. The phalanx systems activate. 2 CIWS mounts, 20 mm Gatling guns. Rate of fire, 4,500 rounds per minute. These are last-ditch defenses. The phalanx engages autonomous, radar-directed. The first target enters range. The gun rotates, fires, burst mode. 50 rounds, direct hit. The target explodes. Second target, another burst, hit. Third target, miss. The target is maneuvering. Fourth target, hit. At 22:29, combined systems have reduced the threat to 18 inbound. HELIOS destroyed 15 total. SM-2 missiles destroyed 28 total. Phalanx destroyed 9 total. 18 threats remain at 1 mile. At 22:29:30, the final defensive layer engages. Everything fires. HELIOS at reduced power. Phalanx at maximum rate. Emergency VLS launches. The sky fills with tracers, missile trails, laser designators sweeping. At 22:30, final count. 3 missiles penetrate all defenses. They're terminal. Impact inevitable. The ship's countermeasures deploy. Chaff, decoys, electronic warfare. 2 missiles are decoyed. They veer off course. Impact the ocean 200 meters from the ship. The third missile stays on target. At 22:30:15, impact. The missile strikes the ship amidships. The warhead detonates. 400 pounds of high explosive. The blast penetrates the hull. Damage control teams respond, flooding in 2 compartments. Casualties: 14 wounded, 3 killed. The ship's combat capability remains, but the perfect defense failed. At 22:35, damage assessment completes. The HELIOS system is intact. It functioned, but not as predicted. Total engagement statistics: 50 inbound threats. HELIOS destroyed 15, SM-2 missiles destroyed 28, Phalanx destroyed 9, 3 penetrated, 1 hit. At 2240, the after-action analysis begins. HELIOS performance versus predictions. Predicted kill rate, 20 per minute. Actual kill rate, 11.25 per minute initial, dropping to 4 per minute in adverse weather. Predicted effective range, 8 miles. Actual effective range, 7.8 miles clear conditions, 2 miles in rain. Predicted reliability, 95%. Actual reliability, 82% when accounting for thermal throttling and weather degradation. Necessary defense or catastrophic overreach. The technology works, but it's not a silver bullet. At 2250, the tactical debrief highlights lessons. Directed energy is effective against certain threats in certain conditions. Clear weather, slow targets, non-reflective surfaces, but it degrades rapidly in real-world conditions. Rain, humidity, sea spray, dust, smoke, target countermeasures. The traditional kinetic systems proved more reliable. SM-2 missiles, 14 hits from 16 launched, 87.5% success rate. Phalanx, 9 hits, approximately 11 engagements, 81.8% success rate. HELIOS, 15 hits from approximately 18 attempts, 83.3% success rate. Comparable. But the missile engagements were at longer range, less pressure. The HELIOS engagements were close range, high pressure. When the laser failed to kill fast enough, the ship was exposed. At 23 mile, the strategic implications are assessed. The Navy invested $180 million in HELIOS development. Procurement cost for ship installation, $25 million per unit. Planned deployment, 50 destroyers over 10 years. Total program cost, $1.43 billion. The promise, unlimited ammunition, low cost per shot. The reality, effective but not revolutionary. HELIOS works best as a supplementary system, not a replacement. How many interceptors can one destroyer launch simultaneously? A. 24B, 96C, over 200. At 2315, Command receives the combat report. First real-world test of directed energy naval defense. Result, mixed success. The technology performed, but didn't dominate. Recommendations, continue development, improve weather resistance, increase power output, enhance cooling systems, but maintain traditional defenses as primary. At 2330, the ship's crew conducts maintenance. The HELIOS aperture is cleaned. Salt spray accumulated during engagement. The cooling system is checked. Minor overheating detected, within acceptable parameters. The generators are inspected. Power draw was sustained for 15 minutes. No issues. At 2345, intelligence analyzes enemy tactics. The mixed missile and drone attack was designed to test defenses. Some targets had reflective coatings. Some maneuvered unpredictably. Some attacked during weather changes. The enemy knew about HELIOS. They tested its limits, and they found them. If combat power decides wars, type combat power. The combat data is clear. Directed energy weapons are not game changers yet. They're force multipliers. In perfect conditions, a 300 kilowatt laser can defend a ship with unlimited ammunition. In real conditions, it's another tool in the defensive suite. The economic analysis is revealing. HELIOS destroyed 15 targets at $1 per shot. Total cost, 15 SM-2 missiles destroyed 28 targets at $3 million per shot. Total cost, $84 million. Phalanx destroyed 9 targets at $30 per round, times 50 rounds per engagement. Total cost, $13,500. The laser is by far the cheapest, but it wasn't the most effective. Effectiveness matters more than economy when the ship's survival is at stake. The answer to the quiz: modern destroyers can launch over 200 missiles through vertical launch systems, and this scenario demonstrates why that capacity remains critical, even with directed energy weapons. As the laser's weather-dependent performance means kinetic interceptors are still the most reliable defense in variable conditions. What would you order next? The Navy must decide the future of directed energy. Options: accelerate development to overcome limitations, deploy current systems as supplements to traditional defense, or reduce investment and focus on proven kinetic systems. The technological gap between theory and practice is clear. Physics works perfectly in laboratories. Combat introduces variables that laboratories cannot replicate. The strategic question: how much to invest in emerging technology versus proven systems? Subscribe to Combat Power, where raw force decides survival. Can directed energy replace traditional naval defense? Should development continue despite real-world limitations? Is weather the insurmountable obstacle for laser weapons? When does pursuing technological advantage become a liability?